Here's a little battery balancing board you can get online. This general architecture. It'll vary 8 cells, 16 cells, whatever, but that's what the general architecture you'll see it look like. So this is the spec sheet, and some of the important things to notice is the working voltage range, 2.2 volts to 4.5 volts, that it doesn't start balancing until it sees a 0.1 volt or 100 millivolt difference, and that it says once it started, it should be able to pull down within 30 millivolts. It says it can do about 1.5 amps of balancing current. But as we're about to see, the interesting thing about this particular board, and that it is energy transfer, it's not burning it off, but that it's 100 millivolts between adjacent cells. So here we see a graph where the numbers of the cells are the sequence in which the batteries are. So minus the positive of the 8-cell pack. The colors show you where it is in voltage. So they're not in sequence that way. Now, we start off with nothing, and then we start applying a charge current, but we're only applying it to one cell, cell number 8 at the top. So we see, because we're doing that, because we see the other voltages going up of some other cells below it, that is verifying that it is an energy transfer style balancing mechanism, and that it is trying to balance that. But we'll also notice that it's not doing it across the board, and it's not even keeping up with the misbalanced charge that we're applying. Here we see we're doing a small 500 milliamp charge in series across the whole 8S string. And you'll notice that in this case, the transfer balancer is doing a much better job pulling the pack together over time, mainly pulling the lower cells up. It's not doing so much of pulling the up and down, it's just pulling the bottom up is the main thing we see there. So here we're on a discharge, and again, it's trying to balance, and we're not discharging very fast or anything here, but it's slowly going over the time. And then here we see we're just letting it go. The discharging has stopped until all the lights go off. And we're seeing that some balancing is still going on. The important thing to notice here is that it has now reordered the cells so that the lowest voltage is at the closest to the minus terminal and the highest voltage is close to the positive terminal. So there's a voltage increment going down that series string, and the whole delta V, or difference in voltage across the entire 8S string, is more than the 100 millivolts that would trigger a balancing current between adjacent cells. So it is balancing, but it might not trigger that at, say, 99 millivolt difference between adjacent cells. And once it starts balancing, it'll go down to maybe that 30 millivolts between adjacent cells. But over a multiple series string pack, that 30 millivolts can add up because it's not common across all of them. It's only from adjacent cell to adjacent cell to adjacent cell. So here we're continuing to let the little balancer try to do its job, and you supply a charge current and it balances things off a little bit, and then we do a discharge and it pulls it off a little, and then we're going to go through some cycles, and there's a little bit of variation. We're noticing it does a better job on the charge side than on the discharge side, and there's some fluctuation between cycles, but we're around 3 amp hours is what our usable is in this range. Now, the PowerLab 8 is the device. So when I turn on its balancing ability, take off this transfer balancer, PowerLab 8 does balancing by bypassing current from a cell. So they're all in series, but instead of one cell, it doesn't burn it off as heat, and it doesn't transfer it to another cell, it just bypasses it. So for instance, that top cell here, which has the highest voltage, is getting less current to it than the other ones. The current is applied to the whole series string, but then the higher ones are bypassed. But because it's referencing the whole battery pack, you'll notice it gets the whole thing much, much tighter. And then when we go to discharge it, here we finish charging, and then we go to discharge, we end up getting more amp hours usable out of the battery pack because of this mechanism. Not because of the bypass mechanism of how it balanced, but because it had the threshold, or the balancing differential, dV, that it would allow in a battery pack was a common bus across the entire battery pack, and not like we saw the other one, which was just between adjacent cells. So therefore, it can't be stacking an error, and the error is across, a such and such delta V difference is across the entire battery pack. We see a similar effect on the previous video, link in the description below, on DeliGreen energy transfer balancer. That is an energy transfer. It's a lot bigger than the one we were testing today. And it has more idle or standby current, but it does have that common bus to allow a common voltage line, so that there's a lower deviation across an entire pack.